Welcome to Mathematics for All by Neomath. This is Algebra Basics Part 2 video. Topics covered in Algebra Basics Part 1 video are: what is algebra, why we use letter in algebra, expression, structure of an expression, types of expression, arithmetic expression, algebraic expression, constants, variables, terms of an algebraic expression, structure of an algebraic expression, and coefficient. The link is given in the description box. Please check it. So in this session we are going to discuss introduction to polynomials. Topics to be covered are: what is polynomial, structure of polynomial, difference between algebraic expression and polynomial, polynomial in one variable, degree of polynomial, constant polynomial, zero polynomial, classification of polynomial, classification of polynomial based on number of terms, that is monomial, binomial, trinomial, and based on degree of polynomial, linear polynomial, quadratic polynomial, cubic polynomial. So what is polynomial? Poly means many, nomial means terms. So polynomial means many terms. So polynomial is an algebraic expression in which the variables involved have only non-negative integral powers. What is that non-negative integral? It means positive integers, that is whole numbers. So 1, 2, 3 and so on, the set of whole numbers. The power of variable here is whole number. Now we discuss structure of polynomial. Constant into variable to the power whole number. For example, 8x square. 8 is a constant, x is a variable, and 2 is a whole number. So it is a polynomial. 4x power 1 by 2. 4 is a constant, x is a variable, 1 by 2 is a rational number. So it is not a whole number. So 4x power 1 by 2 is not a polynomial. 6x power root 2. 6 is the constant, x is the variable, and root 2 is not a whole number. So 6x power root 2 is not a polynomial. Let we discuss the difference between algebraic expression and polynomial. Algebraic expression, polynomial. The structure of algebraic expression is constant into variable to the power rational number. But for polynomial, constant into variable to the power whole number. So for algebraic expression, the power of the variable is a rational number, and in polynomial the power of the variable is a whole number. For example, 8x square. So 8 is the constant, x is the variable, 2 is a whole number which is a rational number. So this is an algebraic expression. 4x power 1 by 2. 4 is the constant, x is the variable, 1 by 2 is a rational number. So it is an algebraic expression. 6x power root 2. 6 is the constant, x is the variable, root 2 is not a rational number, it is an irrational number because it is a non-terminating, non-repeating decimal. So it is an irrational number. So this is not an algebraic expression. Here in polynomial, 8x square, 8 is a constant, x is the variable, and 2 is the whole number. So it is a polynomial. 4x power 1 by 2. 4 is the constant, x is the variable, 1 by 2 is not a whole number, so it is not a polynomial. 6x power root 2. 6 is the constant, x is the variable, root 2 is not the whole number, so it is not a polynomial. So second point. So we know that the structure of the algebraic expression is constant into variable to the power rational number, and polynomial is constant into variable power whole number. So 8x square is an algebraic expression, 4x power 1 by 2 is also an algebraic expression. So 8x square is a polynomial, but 4x power 1 by 2 is not a polynomial. So all algebraic expressions are not polynomial. 4x power 1 by 2 is a algebraic expression, but it is not polynomial. But all polynomials are algebraic expression because whole number is part of rational number. So all polynomials are algebraic expression. Polynomial in one variable. So a polynomial that contains only one variable is polynomial in one variable. For example, 3x square plus x power 4 plus 6x. So in this polynomial we have 3 terms. In all the terms we have the variable x. So it is a polynomial in one variable x. The second example is 5y plus 3y square. So it has 2 terms. In both the terms we have only one variable y. So it is a polynomial in one variable y. The third example, t cube plus 2t. So in here we have 2 terms and these 2 terms have the variable t. So it is a polynomial in one variable t. So what is not polynomial in one variable? A polynomial that contains more than one variable is not polynomial in one variable. For example, 3x square, xy, 6y. So here we have 3 terms. So in the first term we have the variable x, and in the second term we have the variables x and y, and third we have the variable y. Here we have 2 variables x and y. So it is a polynomial in the variable x and y. So it is not a polynomial in one variable, but it is the polynomial in 2 variables. Next, 5x plus 3y square. Here in the first term we have the variable x, and in the second term we have the variable y. So this is not polynomial in one variable, but it is polynomial in 2 variables x comma y. The third example is a cube plus 2x plus ab. In the first term we have the variable a, and the second term variable x, and third term a and b. So this is not polynomial in one variable. This is polynomial in 3 variables a, x and b. So identify the polynomial in one variable. 5x. Is this polynomial in one variable? Yes, we have only one term, and in this we have only one variable. So it is a polynomial in one variable. 7x plus 1. So here we have 2 terms and there is only one variable x. So it is a polynomial in one variable. 3x square plus x power 4 plus 6y. So here we have 3 terms and here we have x and y. We use 2 variables. So this is not polynomial in one variable. This is polynomial in 2 variables x comma y. So this is not polynomial in one variable. 5y plus 3y square. In both the terms we have the variable y. So it is polynomial in one variable. 2t cube plus 2t plus 7t plus 10. So this polynomial has a variable t. So it is polynomial in one variable. 3x square plus 2xy plus 6y square. So this expression has 2 variables x and y. So it is not polynomial in one variable. Next is degree. So the degree of the polynomial is the highest degree of any of the terms. That is the highest power of the variable in a polynomial. So for example, x square plus x plus 3x power 5. Here we have 3 terms, x square, x and 3x square, 3x power 5. So the power of x in the first term is 2 and the power of x in the second term is 1 and the power of x in third term is 5. So the highest power of the variable x in this polynomial is 5. And so the degree of the given polynomial is 5. So we have to look for the highest power of the variable in the given polynomial. So finding the degree in polynomials with one variable. So 3x, the highest power is 1. So the degree is 1. 5x plus 3x square. Here we have 2 terms. 5x, the power of the first term, the power of the variable in the first term is 1 and the power of the variable in the second term is 2. So the highest power is 2, so the degree 2. X cube plus 2x. Here we have 2 terms, x cube and 2x. The power of x in the first term is 3 and the power of x in second term is 1. So the highest power is 3, so degree 3. 3x square plus x power 4 plus 6x. Here the first term is 3x square, second term is x power 4, third term is 6x. The power of the first term is 2, that is the variable, the power of the variable x is 2 and the power of variable x is 4, and the power of the variable x in the third term is 1. So the highest power is 4, so it is degree 4. And the next example is x square plus x plus 3x power 5. Here we have 3 terms. The first term is x square. So the power of the variable is 2, and the second term the power of the variable is 1, and the third term the power of the variable is 5. So the highest power is 5. So it is degree 5. So what is constant polynomial? Any number except 0 can be called as constant polynomial. So let me discuss the structure of constant polynomial. Constant into variable to the power 0. For example, 8. So 8 can be written as 8 into x power 0. So the degree of non-zero constant polynomial is 0. So the degree of 10 is 0. The degree of 8 is 0. Clear? So any number except 0 can be called as constant polynomial. The degree of non-zero constant polynomial is 0. So next is zero polynomial. The number 0 can be called as zero polynomial. The structure of the zero polynomial is constant into variable to the power whole number. For example, 0 x power 5 so is 0. Okay, so the degree of zero polynomial is not defined. It is very important. There is a degree of zero polynomial is not defined. Clear? Classification of polynomials. Polynomials can be classified based on number of terms and based on degree of polynomial. Based on number of terms, we have monomial, binomial, trinomial. Based on degree of polynomial, we have constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial. So first, classification of polynomial based on number of terms. Monomial, it is a one term polynomial. It has only one term. For example, 3x. 3x, it is one term polynomial, that is monomial. 3x square. 2 is a constant polynomial which is a monomial. 0 is also a monomial. Next, binomial, it is two term polynomial. Examples are 5x plus 3x square. Here we have two terms. 5x is the first term, 3x square is the second term. So it is binomial. Second example is 2x plus 5. Here also we have two terms, 2x and 5. Next is trinomial, three term polynomial. So here we have three terms, x cube plus 2x plus 10. So the three terms are x cube, 2x and 10. So polynomial based on number of terms or monomial, binomial and trinomial. Next, classification of polynomial based on degree. So linear polynomial, that is a polynomial of degree 1. For example, 3x. So we have to check the power of the variable, highest power of the variable. Here the highest power is 1. So degree 1. So it is a linear polynomial. 3x plus y. Check the power of the variable, highest power of the variable. Here highest power of the variable is 1. So it is linear polynomial. Next is quadratic polynomial, polynomial of degree 2. So 5x plus 3x square. Here we have two terms, 5x and 3x square. The power of the first term, the power of the variable of the first term is 1 and the power of the variable x of the second term is 2. So the highest power is 2. So it is quadratic polynomial. X square is also, the degree is 2. So it is quadratic polynomial. Cubic polynomial, polynomial of degree 3. X cube plus 2x plus 10. Here we have three terms. First term, the power of the variable x is 3 and in the second term the power of variable x is 1. So the highest power is 3, so the degree is 3. So it is cubic polynomial. So we can classify the polynomial based on the degree as linear polynomial, quadratic polynomial, cubic polynomial. So a polynomial in one variable. Polynomial in one variable means it has only one variable. So a polynomial in one variable x of degree n. Degree means how do we find out degree? It is the highest power of the variable in the expression. So a polynomial in one variable x of degree n is an expression of the form an x to the power of n plus a n minus 1 x to the power of n minus 1 plus and so on to a1 x plus a0. So where a0, a1, a2, a power n minus 1, a power n are constant value, that is a numerical coefficient, isn't it? And an should not be equal to 0. So this term should not be equal to 0. If this becomes 0, if an is 0, then the degree will be n minus 1, that is x power n minus 1. N minus 1 will be the degree. So but our degree is n here, so an should not be equal to 0. For example, 5x power 5 plus 3x power 4 plus 2x plus 10. So this is a polynomial in one variable, because here we have only x. We have only the variable x, so it is polynomial in variable x, and degree is 5, isn't it? So degree is 5. So if the coefficient of x power 5 is 0 means then the degree becomes 4, isn't it? So this terms, the value of this term becomes 0, so we get the degree 4. So this coefficient of x power 5 should not be equal to 0 if the degree is 5. Clear? So if a0 is equal to a1 is equal to a2 is equal to an minus 1 is equal to an, that is the numerical coefficient of all the terms, or 0 means then it is a 0 polynomial. Clear, children? So in the next video we will discuss class 9 mathematics chapter 2 exercise 2.1 problems. Thank you.